Hey guys, welcome to LeetCode 169 majority element. In this challenge we are given an array nums of size n and we are to return the majority element. The majority element is the element that appears more than n over 2 times. You may assume that the majority element always exists in the array. So in this case, let's say we had an example array of 22112. In this case, our n over 2 equals 2 because this is actually 5. And therefore our majority element, which is 2 here, occurs 3 times greater than 2, which is true. And therefore we would return 2 as our majority element. We can do this in a very literal sense because we are given this statement which states that you may assume that the majority element always exists. So in this case we can very simply sort the array and then find our middle index and return that as our majority element. However, I will also provide a bit more of a sophisticated algorithm for if this didn't exist, if this statement didn't exist, we would be able to then still provide some kind of solution. And that solution, or that algorithm, is called Boyer-Moore majority vote algorithm. And so in this, what we'd end up doing is we'd have a count, right? A count, and we'd have a current candidate. And with that current candidate, we will be comparing it to our current index. And if they are equal, then we will increase our count by 1. If they aren't equal, then we will decrease our count by 1. So in this case, we would start with our current candidate being 2. We'll compare it to 2. It means our count is 1. We will then compare it to this 2, to index 1, which would then mean our count would then become 2. And then we'd compare it to this 1, which would then we would decrement our count, so that would go down to 1. We'd then compare it to this, so now we'd go down to 0. However, we will only change the candidate should we reach a negative number. So should we reach -1, we would then change our candidate to be the current index and see where we are from there. But in this case, because we haven't reached -1, we're on 0, we can then move on to the next index, which is the same. So we have a 1, and therefore we will return 2 as our majority element. And so if we look at this in the code, this will look a little something like this. So the first solution, which is very simple, would be something like array sort nums. Oops. Why is that not working? Let me use my mouse. There you go. And then we would then do return nums square bracket curly bracket nums dot length divided by 2, and this, close this, return, and we would then get a result that looks like this, which is great, works, nice, no problem, very simple. However, that only exists in the situation that we are given the fact that there will always be a majority element. Now, if there isn't a majority element, which is possible, what we would do then is, so I'll just comment this out. We would then use something like the Boyer-Moore algorithm, which states, so, well, it doesn't state anything, it works like this. So we'll initialize a count, we'll initialize our current index, which equals nums, nums 0. And then we use a for loop, which in this case, int I equals 0, I is greater than nums dot length, and we will increment. And so in this for loop, if our current is exactly equal to nums I, this is our comparison that we were talking about earlier, then we will increment our count by 1, right? However, if this is not the case, so in this case, an else statement, we will decrement by 1. And therefore, this gives us our count. So then we will then compare our count, or we'll always be comparing our count. In this case, we'll use another if statement. So if our count is equal to -1, then we want to do two things. So we want to change our current candidate to be the current index in our array. And we want to reset our count to 0, right? And then what we aim to do then is return our, current, not our count. And that, if I go to the result thing here, once I submit this, we will have a faster runtime. It's a bit odd. Normally this produces a much faster runtime, but we would end up with a much better, more complex solution that does work and can, if the array doesn't have a majority, then we can just account for that essentially. However, this doesn't return anything if the array doesn't have a majority. It will kind of fail, but this is a much better solution to that because it does count for, it does essentially count whether there are an actual majority or not. And so anyway, I hope that helps. You see, why does this not return? This normally returns a lot faster. Oh, there we go. How weird. Anyway, hope that helps. Like, subscribe, and thank you guys. Bye-bye.